Network troubleshooting using Wireshark.
The subject of our video today is going to be the Hero cable installer. So since I started making these videos, I've had a number of you reach out to me who work as cable installers, internet installers for telcos, and you run into situations where clients are constantly calling you about internet issues, and you're either dealing with it remotely or you actually get dispatched to their house, and you have to basically prove your innocence to clients who are otherwise upset about the fact that internet's not working well. So what I wanted to do is create a video just for you and keep it fairly high level, but show you some very practical tips to actually be able to diagnose and ensure that the internet quality of that house is good. So our scenario looks like this. And what I want to use this diagram to do is illustrate really what it means to have internet service and what is the responsibility of the ISP and what is the responsibility of the user. So what does it mean when we say we have internet service? Well, the internet is effectively a set of networks, right? So on the right here, I have a cloud that represents the internet, but this is obviously expansive across the globe. But think of it like once you've hit the internet, you've hit the public space where there's dozens, hundreds, thousands of networks all connected together. The ISP's role is to get you onto the internet, meaning to allow users who use the ISP to connect from their home or their business through their network to the internet. So the way that traffic would flow is that from your home router, you connect to the ISP. This is two ways. The ISP then connects onto another network, usually a much larger network, which provides it access to this big collection of networks called the internet. So when it comes to internet service, really the ISP is responsible for getting data from your home router, your home network, or your business router, business network, to this point successfully, okay? It is not responsibility of your ISP to ensure that everything within the home is healthy. And what do I mean by that? Well, once you've hit this point here, the router, you can have, for example, a bunch of different PCs connecting to the router via Wi-Fi. And say that there's like a microwave going off all the time in this house, or say that there's a lot of stonework in the house that's blocking RF signal, or say that there's you're near electrical lines, right? The house is near electrical lines, and because of that, Wi-Fi doesn't work well. Well, that's not really the responsibility of the ISP, right? Those are factors that are out of the control of the ISP that happen within your house. And if you're the cable installer or cable technician, you often get blamed for all this stuff, right? In all of my experience of dealing with internet access, and when someone can't connect, say, from this PC to, like, say, a web server up here, right? Oftentimes the user will blame all of this, right, for issues, which is the ISP. Really, ISP is from here to the internet. When really their house, the probability that the disruption is somewhere within their house is like, 10, 100 times more likely than it is that this enterprise grade network infrastructure is going to be causing a problem just to you, okay? But it's hard for you to prove that unless you have the tools and tricks to do that. As a cable installer or cable technician, what you want to be able to do is really prove out that this segment here, from here to here, is healthy, right? And if that's healthy and you have evidence to show that, you can show the customer and show your boss, then really whatever else is happening, they need to troubleshoot on their own or get additional help to do that, because you're not there to troubleshoot people's individuals' PCs or iPhones or whatever. You're there to make sure that this service here is healthy. So let's get into one more segment on theory, and then we're going to get into the tools. So before we get into the actual techniques, we really need to discuss what it means to have quote unquote good internet or quote unquote bad internet. Because usually what people will do when they want to test internet quality, right, and this goes for technicians as well, is they'll run a speed test. And what does a speed test do? So this graph is showing you two things. It's showing you throughput, so your speed, and it's showing you time. So it's speed over time. And when you run a speed test, so like speedtest.net, what you do is effectively you ramp up your throughput until you hit some point at which you're capped. So this is usually your max bit rate. This is what you pay the ISP for, whatever, 100 megabit per second, 1 gigabit per second. That hits the flat line, and then once you're done your test, it goes down. Okay? And oftentimes people mistake that for an internet quality test, because really all you're doing during this test is at one point in time. Okay, so let's just say it's like this T here, this time. You're measuring whether or not you can get data through this pipe. You're not measuring things like packet loss, right? You're not measuring things like jitter. You're not measuring things beyond this window. So say, you go into someone's house and you run the speed test once and say it runs for 30 seconds, okay? Well, you're only really proving out that you can transfer a lot of data for 30 seconds. Internet quality is a function of time, meaning you need to have reliable connectivity to and from wherever the network is that in question. So in this case, it's a network between your home and the internet all the time. It's not good enough that you just have a period of time like this. Case in point, I was talking to a user in the chat a few days ago, and they were having issues where most of the time things were fine, right? They got good speeds, everything was working fine. And then occasionally they get issues with latency where the speed only gets to here and it goes down, or gets to here, it goes down. And they get huge amounts of packet loss that they can't account for. If you just run a speed test for 30 seconds, you're not going to catch that. Because ultimately, the parameters that make up the network, all the different components that are in this network, right? You think about here to here, it's not just three things, right? The router, then you have physical cabling, then you have multiple layers of connectivity between usually like the local hydro company to the ISP. Then the ISP has dozens, if not more, routers and switches in their network. Then you got to connect to an internet provider, and that's also more cables and routers and switches. All those things have to work nominally all the time to ensure that from your home router or from your business router, traffic can get to the internet successfully, right? And that's why speed tests often are a bad test of actual internet quality, because internet quality, again, is a function of time, meaning you need to make sure you have good quality internet all the time. So what we're going to do is the tests that we're going to run are actually going to be able to help you run extended tests against that circuit to ensure that the quality is good. Okay, I promise last thing before we get to the techniques. So the techniques we're going to show are going to be testing a couple things. And really what we want to do is be able to run a test that runs traffic through the home router, through the ISP network, and to the internet, right? So what I want you to do, if you are the actual cable installer or cable technician, if you're going to be running these tests, what you need to do is use your laptop. Usually you have a field laptop, and you need to plug yourself in directly to the home router via Ethernet cable, okay? Do not use Wi-Fi. Plug directly in. Most of you probably do this already, but just in case you haven't done this before. And if the user has another, like say a switch or something, and then that connects to other PCs, don't connect to this. Connect directly to the router that you provided to the customer. Now, if it's a router and a modem, like some people will have a router and they actually have a modem here, and then that modem connects this way, then connect into the modem, okay? What we're going to be doing is doing a couple of tests. We're going to be looking for a generalized packet loss to connectivity to the internet, and we're also going to be doing a ping test to something over here. I'm going to say this is Google. Now, why do we do a ping test to Google? We do a ping test to Google because when I do a ping test from this PC, it's sending traffic from here to the router, through the ISP network, to the internet, and then to Google. And Google is a good anchor, so to speak, meaning like, if you actually do experience packet loss, it may be with Google. Like say, any one of these things could be the culprit, right? It could be your home router, ISP network, internet, or Google. It could be Google. Chances are it's not Google. Google, when they have their monitoring set up, if there's any sort of issue with their networking, they know before anyone else. So that's why we use Google as a good anchor to do testing against, okay? So the tests we're going to run are going to run through the router to the ISP and to the internet. If that is good, if you're able to validate that connectivity through these components is all good, well, then the issues are probably going to be somewhere in here. Okay, so let's get to it. All right, so the first thing you want to do from your laptop, so again, it is this laptop here plugged directly in. You want to open up a command prompt. Now from the command prompt, we're going to do a couple things. We're going to run a ping test to Google, but we're going to do it in a way that you can actually collect the data and and log it so that you can actually have evidence for later. So the first thing you want to do is run the date command. Now date/t will just display the date. Time/t just displays the time. And what I want to do is put these into a log file with my pings so you have evidence of when you actually ran this test. So I'm going to do date/t // log.txt. I'm going to do time/t / log.txt. And what this is doing, what the forward brackets are basically creating this log file and adding the outputs to that log file. So if I were to open that file, let me get it open in my window. Just bear with me. Here it is. I'll open this up so I can show you as we go. You can see I've got the two lines here, right? It's March 13th, 1:29 p.m. So at least my log has some reference points, so when you can actually share this with your boss or with the client, you can say, well, this is the one we ran the test. Now, the next thing is you want to start a ping test to Google. Now, generally speaking, when we do that, we just do ping, pick an IP. So 8888 is what I always use. This is a great IP to remember. It's Google DNS, and it's great for pinging. And I use this -t flag. This just means doing it continuously. Okay, let's do that just to make sure it works. So what ping is showing you is a few things. One, it's going to show you how much packet loss is going to be there with these pings, right? And because you're plugged directly into the modem, this is going to be a good representation of what the user is experiencing or what the actual connection quality is going through your modem to your ISP network to the internet. Okay. It's also going to show you the min, max, and average latency, which is important. And we know that it's working now. So now that it's working, what I want to do is do the same thing, ping -t, but I'm actually going to pipe it into a file. So I'm going to do pipe log.txt. I'm going to let that run. Now, if you want to keep track of it, you can actually open up that file. You could see all your pings are getting generated and thrown into this. And as we go, so if I close this off and open it up again, you'll see it's extending. So what we call this in really the networking industry is an extended ping test. You are continuously sending traffic out and back along this path through the router, through the ISP to the internet, and you're recording if there's any loss, and you're recording if there's any latency. It's kind of like, it's a nice little probe that is like really easy and free to use, but we're letting it run for a period of time. So what I'm going to do, I'm going to suggest you run this for at least 10 minutes. I'm going to run mine for 10 minutes, and then I'm going to come back and show you what it looks like. All right, now while the ping test is running in the background, you can fire up Wireshark, because the next thing we're going to do is take a wide open capture in Wireshark. Now, if you're not familiar about how to do a wide open capture, I'll post a video in the show notes in the description. Basically, we're going to capture all traffic going in and out of our network interface connecting to the internet. Okay, so in this case, on this PC, it's going to be Ethernet. On your PC, it may be a different name, but check out that video to see how to do it properly. Really, it's just finding the right adapter, and then from there, double-clicking on it. And then you're going to see a whole bunch of traffic going in and out. So just like the ping test, we're just going to let this run. I'm not going to download anything special. I'm not going to go to any special websites. Your PC naturally is going to various resources all the time, right? Like Windows Update is going to the internet. You could see I'm not doing anything else on my PC other than recording this video, and I've got lots and lots of traffic from background processes, from things like that. So you don't necessarily have to generate traffic, but what we're trying to do is just capture everything that's going in and out, and then we're going to look for evidence of packet loss after. Okay, so we're going to let this run, let the ping test run. When 10 minutes is done, I'm going to show you what both of them look like. And we're back. So it's been just over 11 minutes, and you can see the ping test is still running. If I want to terminate this, what I do is hit Control and C on my keyboard. And now let's open up the file and take a look. All right, let's see what this looks like. So this is a full log of all the pings that were sent out for the last 10 minutes to the destination, okay, with all the different data points, including the latency. And if there's any that timeout, you would see a message saying timeout. If you want just a nice summary of this, what you can do is go to the bottom and you'll see the full summary of the number of packets that were sent, number received, how much lost. So 405 sent, 405 received, meaning there's 0 lost. That makes sense. And the latency was minimum 7 milliseconds, maximum 24, average 8. The metrics to look at. Number 1, loss. With a ping test like this, loss should be 0 all times. Okay. The exception being, if you're really overloading the circuit, like everyone's downloading at once, you'll see some loss. But if no one's using the circuit, so you just the only thing that's plugged in to this network is your PC, there should be 0 loss. That's the first thing. The second thing is that latency should be reasonable and the spread should be reasonable. What is reasonable? Well, the main thing you want to look at is the difference between the minimum and the maximum and the average. Okay, because that'll tell you whether or not you have a big fluctuation within your latency. If latency, say the minimum was 7, the maximum was like 5,000, and your average was somewhere between, then you have a problem with what is known as jitter. Jitter is how much this changes. But these numbers look fairly good. You have some that go a little bit higher, that's fine, but it's a fairly stable latency. So what this file represents is a log of basically traffic performance or network performance with timestamps and actual evidence of what's happening on the network. Okay, it's not just hearsay. And we ran it for 10 minutes, but you can actually run this for as long as you want. Right? You can say you have time, you can run this for 15 minutes, 20 minutes, half an hour. You can run this for hours if you really needed to. But this allows you to actually use or have a record of actual data on this circuit to show that the actual network is clean or that there's actual problems that you have to look into. Okay, so this is the first technique. This has actually been, I've used this technique in enterprise settings where we're testing out, 100 gigabit per second circuits. It's the same concept. You want to make sure that over time, not just the 30 seconds, you want to test this over a period of time to make sure the reliability is good as far as you can. You can't test it for 24 hours, obviously, but the longer you go, the more accurate your measurement is going to be. So that's the first technique. Now let's go to Wireshark and see what that says. So in Wireshark, I've stopped my capture, and really I just have a lot of different types of traffic going in and out of this interface. For this purpose, I'm not really interested in going into these packets and figuring out what they are. Really what I want to do is spot if there's any obvious packet loss. So there's another video I did spotting packet loss in Wireshark, would be relevant here, but really what you want to do, all of these different lines are packets that are being sent in and out of the server or of the laptop. What you want to see is whether or not you have retransmissions. Retransmissions are when a packet is lost in transit, somewhere in here potentially, and is resent again, right? Because like in TCP, you have to actually resend packets. So the way we do that is we apply a display filter, which is tcp.analysis.retransmission. So you apply that filter, and what you're interested in seeing is obviously that there are some retransmissions here, which is, retransmissions are going to happen. You can never get 0 retransmissions. It's the way the internet is. But the percentage is what you really want to be looking at. Just like how we looked at the packet loss percentage with the ping test, the retransmission percentage helps you understand whether or not this is healthy or not. A general rule of thumb, anywhere above 4% retransmissions will result in serious degradation. Anything below 1% can be accounted for with just regular noise on the internet. So the red line you want to look at is like if this is hitting up 4% or above, plus your ping test shows dirty, right? You have bad results in the ping test, then chances are there's actually something wrong with the circuit between here and here. If the ping test shows clean, and this shows like less than 1% retransmission, that circuit is clean. right? There's not much else you could do as a cable installer to ensure that this is good. This is your responsibility here, right? This is what you provide to the customer. At that point, the customer needs to actually look into some things on their end, like maybe there's some malware on the computer, maybe there is bad Wi-Fi, as I mentioned before. But really, this is just there for you to be able to actually test this out, show them evidence that this is what the result is. And if the result is bad, then you have evidence to actually go back to maybe your, escalation level partners, or even troubleshoot the local router and say like, well, I see some packet loss. I see some retransmissions. Maybe I need to swap some cables. Maybe I need to call the NOC and say, hey, can you check out the connectivity here? Things like that. But at the very least, this gives you an evidence-based approach to troubleshooting this scenario. That's it for this video. If you have any questions about Wireshark or networking, feel free to post it in the comments. We can chat about it there, or you can always send me the capture file to take a look at. I have a Dropbox that I'll send you to send the file. I've also got a Discord server now, so you can check it out, that channel, and join to do the same, post questions about networking, issues you're working on at work, etc. And as always, please like and subscribe to support the channel. Until next time.